Good morning, everybody. My name is Stuart Kinnair. I'm the CEO and co-founder of Interface Fluidics. Welcome to our water sourcing and disposal webinar on using microfluidics to mitigate compatibility risk during water disposal and hydraulic fracturing. Interface Fluidics is a technology company based in Alberta, Canada, that's primary goal is to make extreme condition fluid analysis quick, accurate, and accessible for the energy industry. Our laboratory is located at the National Institute for Nanotechnology in Edmonton, Alberta, and our headquarters are in Calgary, Alberta. Interface Fluidics provides fluid analysis and fluid compatibility studies across a wide range of questions, including frac fluid optimization, enhanced oil recovery, steam-assisted gravity drainage, and other enhanced recovery methods. We also offer PVT and phase behavior methods for minimum miscibility pressures, flow assurance, and other applications. Water management is not just a big challenge, it's also a big business. In the US, the oilfield water management market is more than $37.5 billion. And that's because for every barrel of oil that we produce, we use a half a barrel of water to produce that water, and then 10 additional barrels come out with that oil. With that much fluid coming into contact with each other, fluid compatibility data is truly very key. In the first section of our webinar today, we'll be going through what is produced water, what are the different characteristics of it, and some of the questions that are being asked around how to manage it. Produced water is a complicated fluid. It's high in TDS, can contain hazardous materials like salts, residual chemistry, toxic metals, hydrocarbons, and other chemistry that's found in there. The salinity of this produced water can range from nearly fresh to about 15 times saltier than seawater, which is what you can see on the map on this slide. Disposing of this water safely is a true challenge. The chemical composition of these produced water varies because the broad geology of shale formations and the chemistry that is used in fracking is proprietary. So depending on the end use of this produced water, the amount of treatment that is required is going to vary, and the more treatment that is required, the more expensive this process is. There really are three options when it comes to disposing of produced water: disposal wells, recycling it for additional fracking, or environmental discharge after being treated. When it comes to produced water, it is worth discussing the infrastructure that's required to handle this much water. As you can see in this diagram, often frac fluids with water and other additives are trucked to the site, which are then injected into the wells. Afterwards, wastewater is flowed back through the production of oil and is stored in tanks or holding ponds. That water is then analyzed, may be treated for its end use, which in this case we're going to cover today two applications: the reuse of this produced water or disposal in deep injection wells. On the diagram here, you can see a centralized treatment and storage facility served by pipelines that help reduce the truck traffic associated with moving water to and from well sites. This also eliminates the associated emissions and road damage that's caused. Now, there are many end-use local options for water use, which in this case is water injected into horizontal and vertical disposal wells or re-injected as a hydraulic fracturing fluid. But since the water chemistry that we're dealing with varies significantly by the produced formation, the well, and over time, testing is needed in order to avoid injectivity problems or damage, or treat that damage once it occurs. And so Interface focuses on well-specific testing to identify injectivity risks, identify potential formation damaging risks, and better understand the treatment options that are available to our clients. So as I've said, we're going to cover two topics today: water disposal and water reuse. In this section, we'll go through how Interface works to help producers dispose of their water safely. Disposal wells are wells that are drilled deep into saline aquifers that are not useful for any other purpose. By injecting the water from the hydraulic fracturing into these wells, we're able to dispose of this water safely. Now, the challenge is that disposal well injectivity, or the amount of water that can be injected into that formation, reduces over time. There are many potential causes, but the ones that we work on at Interface are water incompatibilities. that are creating a precipitate that blocks the matrix porosity and permeability of that formation, causing the need for additional wells to be drilled or additional interventions to repair that damage. Water incompatibilities manifest in many different ways, but one of the primary ones is through salt or scale precipitation. Frack and caudate water mixing and block off the formation. Chemical damage can occur due to undesired interactions between the formation fluid and the fluid coming from flowback wells. Drilling and completion fluids additionally contain solids that may also be incompatible with the reservoir fluids. So disposing of these fluids requires testing. As an example, we can see on the screen here an example of when there were significant incompatibilities between an injected fluid and a formation fluid, resulting in 100% damage. Now the question is, can well injectivity be restored after damage that occurs like this? There is chemistry that can help these things, but no one chemistry is equally effective with all applications. And so being able to understand the right way to remediate the damage that's caused by incompatible fluids is also required. Interface Fluidics provides the testing that's needed in order to keep disposal well injectivity high for longer periods of time by mitigating this formation damage. This strengthens the economics of the oil and gas water management, and part of this centralized approach to water treatment is the on-site screening of brine water for compatibility issues. That's where our portable bench Sapphire Lab becomes available. It's faster, uses tiny samples, and is flexible enough to be put on site and test in remote locations. What we deliver with these compatibility studies is the probability of precipitation happening, what's being precipitated, how fast is that damage being caused, the distribution of the crystalline structures, and the different ways that remediation can be performed. So questions like how fast are we able to dissolve the precipitates? As well, we're able to look at how reversing the flow can dislodge those chemistries. So as an example, in the image you see on screen, we see precipitation of crystals that's been caused by incompatible fluids. And what we're doing in the bottom there is quantifying how much of the porous media is covered and blocked by those precipitates over a period of time. So this gives you an idea of the rate that you're depositing the chemistry and how bad it's going to get, how quickly. As I mentioned before, we've covered how we can dispose of water safely. Now I'd like to take some time to talk about how we can enable our clients to reuse their water. Reusing produced water for fracking is something that's done very regularly across North America. The challenge is that these are complex fluids, as I mentioned before, and understanding their interactions with the other essential chemistry for fracking is work that needs to be done up front. For example, high viscosity friction reducers that are designed for fresh water may not have the same viscosity that's required when mixed with saline water. This can be mitigated and dealt with by testing those fluids and identifying their suitability prior to going to the field. Using Interface's flowback or regained conductivity solutions, companies screen through frac fluid additive combinations at reservoir temperatures and pressures to identify which will improve performance or which may cause damage. The fact that we do everything using images and videos allows us to identify chemical incompatibilities and thermal damage that may go otherwise unnoticed in traditional tests like core floods, column drainage tests, or other benchtop bottle tests. By identifying and mitigating the damage that's caused by using reduced recycled water, wells have increased production and flow hydrocarbons for a longer period of time, making them more profitable. At Interface, we're all about helping folks identify and mitigate risk very quickly and very inexpensively. So for example here, creating a formation damage that reduces your hydrocarbon recovery from your oil well is often caused by chemistry that's incompatible with the water that's in there. One of the questions we're often asked is about iron compatibility. If I have iron in my produced water, is this going to be a problem and cause damage in my well? That's something Interface can help answer. Testing these chemistries at representative reservoir temperatures and pressures is essential to understanding how chemistry is going to perform once it's in the well. The chemistry added to frac fluids serves different purposes, whether that's wettability modification, interfacial tension reduction, corrosion prevention, or friction reduction. Every well has a unique blend of chemistry that's designed to meet the specific performance targets for that well. But testing at temperature and pressure in oil and gas has traditionally been a very expensive and challenging process, and is often not done using produced water. So vendors are testing with fresh water at standard conditions. This leaves a large gap in the real-world application of that chemistry versus what it was tested at. Fluid incompatibilities between the injected and formation fluids can cause emulsions, for example, precipitation, or other friction reducer-based damage. Additionally, thermal degradation is often seen at very high temperatures in reservoirs similar to the Eagle Ford, for example, where chemistry can destabilize or break down, causing precipitation and deposition, and ultimately damaging the formation. So on the screen here, you can see three different images of formation damage that was caused during testing that was done in Interface's lab. On the left, we see solids precipitating in the injection portions. The second, we can see wax being precipitated into the porous media, causing a reduction in permeability in that system. And finally, in the bottom right, we can see thermal damage, where friction reducer or surfactant was not compatible with the high temperatures in a client's reservoir. There are three primary questions that our clients come to us when they want to do testing and understand their systems better. The first is, am I going to have formation damage? The second is, I want to reuse my produced water with chemical additives. Can I do that? Is it going to be effective? And the third is the chemistry package that I've selected going to increase or decrease the amount of oil that I produce? The most common way that we answer those questions at Interface is using our flowback test. What you see on the right is a porous media that's been designed to have the same permeability as our client's reservoir. We inject frac chemistry into the oil-saturated porous media, allow that to soak, and then we reverse flow to flow the oil back out of the system, and we measure the amount of oil that's flowed back over time in order to quantify the performance of various chemistries against a baseline. So we can help our clients understand, am I going to produce more oil with this chemistry versus another? Often our clients are looking for a simpler test as well, to understand how friction reducers will interact with the water that they have available to frac with. The goal is to prevent those friction reducers from damaging the permeability of the producing formation. And so what's been developed here is a test called regain conductivity, which is essentially how much damage is done by my friction reducer over the period of time that I'm using it in the reservoir. So this was developed in partnership with Ovintiv and Rockwater Energy Solutions over the last 3 years and has been run hundreds and hundreds of times at this point to identify compatibility between water and friction reducer. What we can see here is that there's a significant difference in the amount of damage that's caused initially, but we also are able to identify how different friction reducers clean up in the presence of varying water compositions and varying chemistries. The beauty of this test is it is an extraordinarily repeatable test with repeatability that's higher than almost any other lab test that's available in the oil field. It has less than 5% variability run to run compared to the 80% variability that is seen in comparable traditional methods. This is a great tool for a quick screening to make sure that we're not going to have problems as soon as we go to frac. With that, I'll wrap up by talking a bit about how our testing compares to other testing that's available on the market, as well as some of the hardware that's available for clients that may want to put this technology on site. Our technology at Interface is capable of performing fluid analysis and fluid compatibility tests at up to 200 degrees Celsius or 1000 bar, or in imperial units, 15,000 psi, and 400 degrees Fahrenheit. Our samples are tiny in comparison to traditional tools. We're using single-digit milliliters of fluid samples, which means that our testing is fast. We don't need to use up valuable core or live samples. And then we do all of this at reservoir condition. Additionally, we're not making any interpreted results. We're using direct measurement of all of the values that we report. So we image the porous media to get how fluids behave and the mechanisms that are driving that performance. Additionally, we're able to match true reservoir nano confinement, which in shales is especially important because those are such tiny pores that running a core flood on this technology for shale is essentially impossible given the economics of that situation, and Interface is able to perform these tests within a day. Now, Interface Fluidics has been working and performing this as a service for a number of years at this point, almost a decade. And what a lot of our clients have said is, I want to be able to do this on site. I want to be able to do this local to make sure that I can do my fast turnaround testing with exactly what's on site. So we have developed what we call Sapphire Lab. This is a deployable piece of hardware that can be deployed to a site where the testing that's traditionally been performed in our facility is now performed wherever it needs to be performed. It includes all the high resolution optical measurements that you get in our lab, but it just allows us to do it on site for our clients there. So with that, I'd just like to wrap up by looking forward. The questions that we're answering here are important, and these environmental concerns aren't going away. Our clients need to keep their wells running at optimal levels to maximize the ROI rather than drilling new disposal wells or new production wells. Our testing is fast, it's cheap, and extremely repeatable, allowing our clients to have the high quality data that they need in order to minimize the damage to their wells and maximize the water storage or hydrocarbon recovery depending on the application. So with that, I'll say thank you very much, and please feel free to reach out to me at info@interfacefluidics.com or reach directly out and comment on this video. So thank you very much. Lastly, our next webinar will be in the third week of January, where we'll be having a roundtable discussion on how microfluidics compares and contrasts to various tests that use the real rock, like core floods and other similar tests. So look forward to that, mark your calendar, and we'll see you there.